In the last video, we oriented the curve that we want the robot to draw from its base coordinate system, so the origin point right here, to our new origin point that we defined as the top left corner of our piece of paper. And we found this top left corner by probing it with the get robot position component, and then setting the origin point, a point on the right and a point on the bottom left, which created this new plane right here. And we then use this orient to location group right here to move whatever we created to this new location. In this video, we will have a further look at how we can prepare geometry for the robot using Retracts, and we will then prepare everything before sending it to our robot. So there are, of course, different pieces of geometry that you might want to use as an input to our robot program. You might want to use points, or you have curves like we have in this case, or you might have 3D data. But regardless of what kind of geometry you want to use, in the end, we need planes to send to the robot. So we don't just need points like we would in a 3D printer, but in our case, we need planes because we also have to account for the rotation, and we have to define the rotation that we want the robot to have at a certain at any of these points. So in our case, for this smooth curve, for example, I use the divide length component to divide this curve and create a point and at a specified distance along this curve. In this case, it's 2 millimeters. And at each of these points, we then create a plane. And in this case, it's simply an XY plane, but for you, this might be different. You might want the robot to have a certain rotation, so you might need to change this. We then want to make sure that the plane points downwards, so that the z-axis of the plane is located downwards, so the robot actually approaches it from the top and doesn't try to approach the point from the bottom. And depending on the type of curve, you might want to use different strategies of getting points and planes from that curve. In our case, this was a smooth curve, so we really wanted to have a lot of data for the robot so that it actually follows this curve accurately. But if you have a polyline, for example, so any kind of jagged line, you might not need that amount of points. So for a line like this, it wouldn't really be necessary to have 100 points, each of them spaced 2 millimeters apart. And it might even be detrimental, because if we use the divide length component here, we might skip over some of the corners right here. So if we were to divide the length, we would go from this point to this point to this point, and then from that point over to this point. And you can see that the robot would basically cut this corner of the curve, and that is something that we really don't want to happen. So in order to avoid this, we can use different ways of getting points from our curve. So in this case, it's a polyline, and I can use the control points component in Grasshopper to simply get the corner points of this polyline. However, this only works for polylines. If you have a smooth curve and you were to use the control points, you can see that the control points for a smooth curve don't really lay on the curve itself. So they're not positioned on the curve, they're actually outside of the curve. And so if we were to use these as our input, the robot would move in a jagged line and basically not follow the curve at all. So make sure that you're using the correct basically division process for whatever curve or geometry you have, and make sure that you then flip the plane. After that, of course, we also have a start and an end to whatever process we want the robot to do. And most of the time, we have some sort of retract. So the robot has been doing its thing. In our case, it's drawing the curve. But at the start and at the end, we want the robot to actually move up or start high above our piece of paper and then move down precisely. We don't want the robot to just start from its base location and immediately go to the first point that we give it. And in order to do that, we retract the first and last plane. And regardless of your process, you will need to have basically an approach point that is used as a safe location that the robot can move to before it then engages whatever process it might execute. In our case, we simply use the first and last plane and move them up by a specified amount. In this case, it's 100 millimeters. And then we merge these new planes back into our list of targets. And here you can see that we have our first point. Then the robot moves down, traces the line, and then it moves back up before going back to its start position. Now, before we continue and actually send the program to the robot, there are a few more things that we can set and adjust. One is the rotation, and the other is the depth. And in our case, our plane or our curve is now located directly on our piece of paper. And this is probably what we want. But we have the opportunity in this adjust depth group that you can find right here to move all of these planes up and down by a small amount in order to account for any kind of inaccuracies when measuring. And it's also a good way of offsetting all of our planes before we actually execute it. So in my case, I want to just move this up by 2.5 millimeters for the first time, or the first time I send it to the robot, to make sure that the robot actually doesn't touch the paper, but hovers above by a small amount. So I can then check if we're actually close to the paper and everything is all right before we then actually draw or do any kind of work with the robot. We already set our tool, but we also have to set our speed. And in my case, this is just 200 millimeters, but we will also set the speed on the robot pendant. So this is not too important, but it's also always good to not have this be too high. But of course, it depends on what you want your robot to be doing. So set this to something around 130. The next thing that we will set is our blend radius. Currently, this is set to 1.0, and this is good for our use case, but for your use case, this might be way too large or way too small. So what the blend radius does is that it basically blends between the robot points. Usually, the robot would just move from one point to the next and stop at each point. So come to a complete stop and then accelerate again to the next point. However, if we want the robot to have a smooth motion, we need to give it this blend radius so that 1 millimeter before it gets to a point, it actually already starts curving towards the next point. And depending on what you need or what you want the robot to do, you might need to reduce this by quite a lot, or you can increase this if you want the robot to be even smoother and move quicker. However, if your blend radius is larger than the distance between 2 points, then the robot might skip a point. So keep that in mind when setting a blend radius. We will currently use the linear motion for all of our targets. If you want to have more information about the create targets component, I made a video and I will link it in the description. But for now, you can just set these values as you see them right here. So after we've set these values, we can check if our robot program is valid. And you can already see that we have a problem here. We have an error in this program. And you can see this here by in the error tab or in the error panel where it says axis 6 is outside of the permitted range. And if we look at the simulation, we can see the robot doesn't even start doing anything. So right from the get-go, the robot tries to do a large rotation, and so the robot's program simply says that's not possible. We can fix this by using the rotate target group right here. And in the front, we have a slider where we can set the rotation of our planes. And this really depends on what you are trying to do and the way you set up your tool. But you will have to basically figure out what a good rotation is for your use case. Of course, in my use case, it doesn't really matter what the rotation is, because no matter how the plane is rotated or the pen is rotated, the robot will still draw. But for your use case, this might matter a lot. So the rotation of each of your targets might be very important in your use case. So this is something that you will have to check depending on what you are trying to do. But you can already see that with this value, in this case minus 189 degrees, we don't get any more errors, and we can actually look at the simulation, and we see the robot moving from its start configuration position to the first point. It moves down, it traces our line, traces all of the points, then moves up, and then it goes back to its starting position. You should always check your simulation before you send anything to the robot, because any errors or any problems that you can spot in the digital simulation, of course, prevent errors and collisions in the real world. So after we've done this, we can send our program to the robot. We do this with the send to robot button right here. However, we have to set our robot to remote mode. And we can do this on an E-Series Universal Robot by clicking in the top right where you see local, set it to remote control. Depending on your robot, you might need to set it to automatic mode before you can set it into remote mode. But in our case, we can simply set it to remote mode directly. I will give this program a name by simply calling it program. You can do this right here in the create unique program name group. And then I can use the upload button in the top left to send it to the robot. And if you're connected to the robot and everything worked out, you will see on the top that your robot program and the current timestamp appear at the top. And now I can set my robot from remote to local control again by going in the top right and hitting local control. Reduce the speed at the bottom just to make sure that the robot doesn't do any super fast movements. And then I can take the pendant, make sure that I face the robot before doing anything. And then I can hit start and start the program. You can see the robot moving to its start position. And then it starts tracing the line we gave it. Now that we've seen that everything is okay, that we can actually send it to the robot, that our values are correct, that the speed is somewhat reasonable, we can change the values, and especially the value for our offset that I set to minus 2.5 right here. I will set it to 0. And now our robot should actually be touching the paper. So I will set my robot to remote mode by going in the top right and selecting remote control. I will send my program to the robot. I will go back to my robot pennant and make sure that the timestamp has updated so that we're actually using the new program. Set the robot back to local control. And then I can start this new program. And now you can see that the robot has executed all of the targets that we gave it. So that's it for this template. You should really go in and use this template to really get yourself, to really become familiar with the way the robot works, to get familiar with this get data from robot component, and to really understand how all of the different values are set. If you run into any issues, you can contact me or leave a comment, and I will try to get back to you and help you out if I have the time.